So hi everyone. We're happy to talk to you about reproducible cloud-based dev environments for Bazel. That's a mouthful.
Yeah, there we go. That's how mics are supposed to work. So I'm Antonio Di Stefano, software engineer at EngFlow.
And I'm Jan, software engineer at Envoy as well. Before that, I worked at Gitpod, which is relevant to this talk. And before that, I worked at Mozilla.
Yeah, and in general, our history is one of engineers that do want to make builds faster, developers faster, and sometimes happier, sometimes not. This time we want to make them happy. That's why we're trying to pair up cloud development environments, CDs, and Bazel, especially with remote execution and such. So our goal is to put everything on the cloud as much as we can, make it fast and make it seamless. So what is a CD? So CD stands for Cloud Development Environment, and it's pretty much what the name says. It's a development environment in the cloud. And it's basically just a server running your IDE, and then you also have your IDE locally connecting to it. And there's a few advantages if you think about it. Because, well, now onboarding is easy. You've created a reproducible environment. It's defined in the code, pretty much like you do with builds, right? And so every time that a new developer is onboarded on a project, you just click on a button and you get the same identical environment each and every time. That also has another benefit that you can spin up multiple environments in parallel. We as engineers try to think that we don't do too many things in parallel. We like to focus. That's not true. We do 500 things at the same time, and we backshed on all of them concurrently. But we are way more parallelized than Bazel if you think about it. But also it centralizes the infrastructure, which means that now a DevOps team can control the infrastructure. They can make it safer because now you can tighten the security boundary. And also you can leverage more powerful machines, right? How many of you have like 128 cores on their laptop? Well, I actually saw a few hands. Like, where are you hiding your laptop? But on the other end, cloud vendors have even bigger machines, and you don't need to keep them all the time if you're just using them every now and then. If every now and then you need like that much power, with CDs, you can use it. And that's actually the same thing with RBE. Like the power comes from having more compute resources readily available at any time and not having to use them constantly. So you have more power, you use it better because now it's a shared resource. But at the same time, you save on costs because you're not always using it and you can turn it down when you're not. Which brings me to the next point. Why would you use CDs and Bazel together if they offer a lot of the same benefits in some sense, right? They make your environment more reproducible. They can make your builds and development faster. So why would you do that? Well, I think the answer is faster and faster. Because if you mix faster and you also mix faster, you get even faster. I think it's like simple math. And in a way, the two things, you can combine them together in a very nice way. Because if now everything is running on the cloud, there is barely anything going on your laptop. Even if you have a bad connection, it's probably still enough to use a remote connection to an IDE, right? Whereas if you were using just remote execution with Bazel, that may have to upload a lot of files, download a lot of files, and that may not be feasible for everyone, whereas CDs do allow you to use remote execution locally, even with a terrible connection in a way. But you can also use CDs to automate the process of setting up remote execution, right? You've all gone through the process of like, if you're using RB, you have to download some credentials, some certificates, whatever. You have to do that manually. You have to set up your config. And that's repetitive. And also it means that you have access to some of these resources. And not every developer may want to have access to the secrets you need to access remote execution. And you can automate that process with CDs because they are a pre-configured environment. And it's centralized. So you may just give access to the source code and to secrets on the cloud development environment, on an AWS instance, but that's never accessible locally, right? And so even you've tightened the security perimeter even more. Now nobody has code running locally. They can't download the code literally. And of course, as someone called Manuel, that you just saw a few seconds ago pointed out, platforms suck, for lack of better words. Whereas dev containers are super simple. They're just containers. We're all familiar with Docker. Very few of us are familiar with platforms. And even those who are really scared. Like sometimes I go to sleep and I think about platforms, and that's just terrible, guys. I don't wish that on anybody, especially Manuel. So let's look at what a demo of using a CDN Bazel looks like.
So we're happy to show you what this looks like when you combine CDEs and RBEs in a smart way to make things as fast as possible for the developer. And as an example for this, we're going to use the Envoy project, which you saw on a slide, but from Manuel. And it's what you need to know. It's a project that uses Bazel, and it's a big project. So if you wanted to contribute to it because it's open source, say you have some feature you want to implement, you have to go through the entire setup just to make your contribution. And if you just had one contribution in mind, maybe you're not going to bother. But the first thing you need to do is to install some tools. So that's like on a brand new laptop, that's going to be Homebrew and Git and Bazel. And you might need various tool chains like Java or Go, or like install a Python stack, etc. So until you get all of these things right, takes some time. It can take minutes to hours, honestly, or days. Then you can clone the project. Cloning the project can be pretty fast, but you might be on a slow connection, or it might be a very big project. But yeah, it's not hours at this point. And then you need to build the code and run the tests. And this is where the RBE part kicks in, because this can take a really long time. Thank you. And so just to clarify, the CDE part is kind of at the beginning of the flow, and the RBE part is at the end. That's nice. They combine pretty well. And with the CDE, what's really good is that you can specify all the tools you need for a project. It's like as a Docker image, for example, and then you have already all the tools already present. You don't need to, like, you can come in, spawn up the image, and get started without having to bother like reading a file that tells you install this, configure this, set up this, etc. And just to, I'm going to steal the setup. Sorry, Manuel. Just to show you what it looks like live, we're going to jump to a demo. And
by the way, in the meantime, feel free to ask any questions and interrupt us.
So I hope this just works. Probably should have tested this before.
Yeah.
I just plugged in the USB-C to HMI. Oh, I do have an HMI. Okay. Very cool. Yeah, didn't have to wait that long. Sorry about that. So I guess I'll zoom in a little bit. So this is the Envoy project. So for the demo, we could do it in 3 parts. For the first part, I guess like I could be jumping into a terminal, Control-C, Control-L. And then like start installing stuff, but that's going to be very boring and take a very long time. But yeah, just imagine I need to install Homebrew and Git and Bazel and Java, Python, Go, etc., etc. This takes a really long time. I did a fork of this project, and I have 2 commits that might be interesting here. The first is setting up Gitpod, and the second one is setting up RBE. So I'm using Gitpod as a CDE because I worked at Gitpod before, and this is convenient, but this could work exactly the same way with code spaces. Basically, you specify the environment in which you want to develop. I guess I can still zoom in a little bit. The environment is basically a Docker image. And so here we have this nice default image of Gitpod, which has the good idea to already contain like all the tools you might need, like Git, Java, Go, Python, etc. This hides a lot of complexity. I could show you the code, but it's going to be a long time as well. And install Bazel. Bazel is the only tool that was not present in this image. And yeah, that's basically it. We also, so it's using VS Code in the browser, and we install the Bazel extension automatically. And what this looks like is I can open this commit in Gitpod. And for this, I can just prefix the URL with gitpod.io/hash with one hand. Like this, enter. And this creates an environment for me. And what this does is it takes the commit, clones it into a dedicated container in the cloud, uses the image that was specified, boots up a web IDE, and beams me into it. And you see this was pretty quick, right? Like this was the step installing the tools and cloning the code. And now it's booting up the IDE. And in a minute, you'll see VS Code or like a web version of VS Code appear. And I'm going to be able to start working on the project, actually, like opening code files, internals. This is taking surprisingly long. Okay, here we go. I'm tethering over my 4G connection, by the way. All right, zoom in a lot. And yeah, so here we're inside a cloud terminal. I could be doing whatever I want, like opening code files, changing code, building. And so here I will, interesting, this is not the correct commit, I guess. Yeah, should work. So the command is Bazel build Envoy. And so you'll see Bazel is already installed, Java is already installed. And I can just start a build. And this is the part where the CDE part becomes less interesting because it automated the setup. But for the build, this is still going to take a while. Actually, I tried building this without RBE. And it took like 6 hours plus, and then I stopped babysitting it and the container timed out. So, but it's definitely not a nice experience. So you get started quickly, but then you have to wait a long time to build on this container. And so it's a good idea to scale out of this container and use more resources. So yeah, I'll just stop it here. That's why we set up an EngFlow cluster. So it's basically giving you a RBE endpoint. So you can point your build to this thing called regolith, and with the right credentials, it's going to work. The commit looks not like this. Open RBE. Yeah, this one. Oh, it doesn't belong to a, oh, okay. I'm not in the, that's interesting. Sorry about that. That was not in the right repository. Okay, here we go. So to configure EngFlow, I just set the address to this endpoint for remote cache and remote execution. And yeah, that's basically it. I specify container image. I use 500 parallel jobs. I use the right certificates that I set up, which are set up this way. This is sort of a cheap setup. It didn't take me long to do, but you might probably want to do something more secure, like having an enterprise secrets manager or something like this. But the point is you can integrate your CDE solution with your enterprise tools like SSO, etc., automate all the credentials. And yeah, so what this looks like is I can, again, open this Git pod. And you can watch me type with one hand. /hash, enter. Same thing as before. Continue. This starts a container. I actually already started another one so that we don't need to wait these few. Well, actually, it's pretty quick. I actually have another container that already has this set up. Let me just check. So this is the user. This is not the right container. Yeah, the problem is you can have so many parallel environments that you no longer know which is which. But you could be working on like one feature, reviewing a pull request, doing some experiment. So this is the one I wanted. Okay, it has the user Bazel RC configuration. And here, when I do Bazel build --config equals EngFlow, this is the new config I added, and then Envoy. I missed EngFlow. Yes, I don't know how to spell my company. That's very cool. And so this is going to be pretty fast. It takes about 2 minutes, which is much better than 6+ hours. So that's already a really huge speed improvement. But there are ways to make it faster. Like you see it downloaded Bazel again this time. Like I guess there would be some, like CDEs have nice features where you can do work ahead of time, kind of like a CI. It watches your source code and starts preparing things ahead of time. So like it could already have downloaded Bazel, done the analysis, etc. And but yeah, here it started the build on the cluster, so we can see it happening live. Here it is currently running, and you can see the console output live, which is going to be the same thing as this, which is very zoomed out. And yeah, so this is just going to take about 2 minutes, but I guess while it's building, do we want to go to questions? We have our first question. I'm just going to give my mic.
So the demonstration looks awesome, I have to admit that. But what about the latency? So I have worked in various kinds of remote environments. They were no near as fast, but they have their advantages, such as uniform setup, pre-installed tools, sometimes pre-cloned repository. But in case there are problems with the internet connection, it just becomes unusable. So how isn't it even possible to mitigate this in some way?
Thanks. I'm happy to take this question. So I love this question, by the way. It's something we hear a lot about CDEs. Since it's kind of remote development, there's this question like, what about the internet latency if you're on a bad network, like on a train or something? And actually, I think it makes it better to use a CDE because the network throughput you need that is critical is the one you use to download large assets. So for example, if you're cloning a big repository, downloading huge dependencies, etc., this happens in the cloud in a data center at data center speed. And the network throughput you use from your device actually only serves, it's kind of like a website, right? Like you load some text, and when you use the terminal or do some coding, you send some text back and forth. So it doesn't actually need that much data. So like if you're on a train, you don't want to be cloning a large repository. You want to be using a CDE. And yes.
But what about code completion? When I type a Facebook post, for example, I can tolerate a lot of latency because I don't want it to respond immediately for every word I type. But when we are typing a program, it's a given that we will get some response immediately within 1 second, I say. And if when you're on a train, there is just no way you can guarantee latency of a second or even 5 seconds.
So that's a really good point. If you do require interactivity from backend services, so things that are running in the container, you might run into some latency issues. Like, for example, the code completion is a good example. If the completion engine is running in the container in the backend. So there, it depends what is running locally in the front end and what is in the backend. So editing a code file happens locally in the browser. So that's really fast. And if you have some language smartness tools running locally in the IDE, I know that some VS Code extensions allow that, then you can have really fast responses. But yeah, if you're triggering a remote action, you might get some latency issues. So you're trading throughput on the back end with interactivity, sort of. So if I'm using the terminal and the network is bad, if I like start a build, you need the time for the start build command just to make its way to the back end. Any more questions? So no more questions. So we can see the build actually took less than 2 minutes this time, but yeah, it takes around 2 minutes. So yeah, pretty happy about the speed improvement. Thank you so much. Maybe I'll just like boast about one thing. It's the build was actually coming mostly from the cache. Like you can see here, almost like 100% of the actions were cached, 8,400 actions. Yeah, just some stats.
Thanks for that. So I have 2 updates. The first one is that now you should be able to use the Google form to register if you're going to come around the building. And the one you care most about is Wi-Fi is working, but oh, I don't have HMI on this one. Great.